Okay, in another video I went through a null hypothesis test using a critical value method. This uses the p-value method. The two methods will always agree, by the way. Just there's advantages to using one over the other, usually just which one is simpler based on what you're trying to show or the data that you have. Okay, so here we have a new video game, and we have a claim that the average rating will be higher than 84. So we do have a sample where the mean was higher than 84. Again, not enough evidence yet to convincingly say that in general the average rating will be higher than 84, but we're at least in the right direction. So let's see if we're significantly above that mark. Okay, so the null hypothesis, remember, will always have an equal sign. We're dealing with the mean again, the average here, and the null is the nothing hypothesis. Nothing's going on, nothing's special, nothing's different. So if that's the case, then we'll say that the average rating is 84. And if, by chance, this game really is better than this 84 as claimed, then we would see a mean of above 84. Remember, don't use the sample mean. We have that data. We know that. That's not interesting. What we're trying to make a decision about is the population mean. So these are the two options. Again, the less than is technically packed into this equals. The only way we can reject the null is by being out in the right tail far enough. But we usually just write an equal sign here just for mathematical purposes. And I say usually, always, just always put an equal sign in the null hypothesis. All right, is it a one tail or two tail? Well, here we go to the question. We want to know if the player rating is higher than. That directional word higher than is why we put a greater than sign here and not the sign that would allow us to reject in either tail. So we can only reject the null if we are far in the right tail. So this is a one tail test. What is our test statistic? So test statistic is our particular shot here, our particular value based on our sample. So we can pop open the calculator, and we're just going to follow this formula here. So our sample mean was 87.5 minus our null hypothesis mean over here is 84. Then we're going to divide by our population standard deviation is 14.3. And by the way, knowing this is what lets us do a z-test. If we only had the standard deviation of our sample of 68 players, we would have to do a t-test instead. Be very, very similar, but it would be a different critical value. Okay, here we're dividing by the square root of n, and we have 68 players. So 68, and we'll grab the square root of that. So this will give us our test statistic. This is our how many standard deviations our sample was above the mean. And we get 2.018. Okay, click it in and we can see that showing up. Shade the area represented by the p-value. So here's where we're either going to shade one, it's always going to be the tail. We're either going to shade one tail or two tails. And here in step one, we already decided we're only shading one tail. So that's the only place we shade. Now, it could have been if we had asked, is the mean rating different from 84? Could be lower, could be higher than. That would have been a not equal to alternative hypothesis. That would have been a two-tail test. And that here, we would have had to click two places to shade the area represented by the p-value because we would have had two tails. But since we have a one tail, we're done there. And the p-value, well, it's going to be whatever this area is. So we can, maybe roughly estimate it at 5, 10%, something like that. So how do we actually calculate it? Well, we know that we have this probability button that z is less than or equal to, but it doesn't let us do greater than or equal to. It only lets us do to the left. That's okay. Let's go ahead and get that value. That's the value of everything to the left of this cutoff. But we want everything to the right. We can see we've already shaded it. That p-value is the area to the right of this z-score. So it's basically 1 minus 0.978. We're needing to go to the right, and this button on the calculator gave us everything to the left. So why did we subtract from 1? Because we wanted the area to the right, and the calculator gave us the area to the left. So we're going to do 1 minus 0.978, and this gives us 0.022. Okay, and we'll check. Oh, whoa, yeah, forgot to do the most important part, the reject or fail to reject. So it says that we're conducting this at a 0.05 level of significance. What that means, this is called an alpha level. We need our p-value to be lower than this standard. Think of it doing the limbo or something, and this is our limbo stick. Our p-value low, the null must go. So did we get below this level? Well, yeah, indeed we did. We got a 0.022. We did get below that 0.055. So since the p-value was less than or equal to level of significance, we do reject the null. P-value low, null must go. So there is evidence to support that the mean player rating is higher than 84. Now we can check.